Waterfall, waterfall. Okay. You are gonna open up your cobras. You're gonna answer this question. You got $100 to buy snacks. What would you buy? Meanwhile, I walk around and check your cobras. I'm gonna play this video for you. Just try to listen to it. I know it's gonna be a little funny. You can laugh, but try to listen to it too. Okay? My kid loves those. Which Doritos? What would you do? Did I check yours out? Alrighty. Meanwhile, I'm finishing up Cobras. I want you to open up your notebook to your focus question number 4. And I want to make sure that you have it. So open up your notebook to question number 4. Yup. You wrote it down last week. Huh? When? Last week? We took a test last week on Wednesday. question written down? Who's the notebook? Put your cobras away. Everyone should have their cobras away now, please. Cobras away. If you don't have focus question number 4, make sure you write it down. We're going to talk about that today. Yep. That's what we're going to talk about today. Focus question 4. Let me see. Thank you. Tyler. Focus question number 4. Got it. Thank you. Everyone, can I come back to you? Focus question 4. No, I just want to make sure you have it written down. Yes. Yep. And then if you just write me. Okay. Yep, you have it. Focus question number 4. Focus question number 4. Who is I coming back to? Here. Okay, write that down on the board. Okay. It's also on that board. Alrighty, so I'm gonna zoom out a little bit. We've been talking about Earth history in this whole unit. And we've been trying to take out pieces of information that the Earth can tell us, right? So we talked about the rocks that are part of the Earth, right? How many types of rocks are there? Show me with your fingers. 3. There's 3 types of rocks, remember? It is igneous rocks, metamorphic rocks, and sedimentary rocks. We talked about sedimentary rocks first, and there are 3 of those: sandstone, limestone, and shale. And then sedimentary rocks are the only rocks that hold fossils, right? Remember, fossils are not rocks. Fossils are not rocks, but they are the only rocks that hold the fossils. And then we talked about igneous rocks. And how many types of igneous rocks are there? Show me with your fingers. 2. There's intrusive and there's extrusive, right? So what do you think we're going to talk about next? Probably metamorphic, right? That's the last type of rock we got to look at. But in order to go through metamorphic rocks, we need to understand some processes that the Earth goes through. So fossils can actually count as one of those things, like how does the Earth interact with each other. But the other thing we're going to talk about today is Alfred Wegener and Continental drift. So your goal for today is to be able to reconstruct his map, explain and critique his hypothesis. Okay? So 2 things: reconstruct his map, and then tell me about his hypothesis, tell me a good thing, and tell me a not so good thing that he thought. Okay? So in your table of contents, go ahead and write today's date, 10/20. You're going to write Continental drift, table of contents, and then that next page should be around 33-ish, 34-ish.
Mine's 35.
Continental drift. Oh, 10/20. Continental drift. Continental drift. Come on, Jerry. Continental drift. And then the next blank page you have. Love it. continental drift. So what we're going to do today, we're going to watch a short video on Alfred Wegener, what his theory was, and I'm going to give you a hint. The theory is called continental drift. And then we're going to talk about it, okay? So this was set in the 1900s, which if you think about it, was only 110-ish years ago. That was not that long, Zia. That was not that long ago, right? I know it feels like 100 years feels like a long time, but in reality, your grandparents didn't know about this theory, or they were barely learning about this theory when they were little. That's how recent it is. That's how science works. Sometimes we come up with new things and it's a whole big deal. Yeah.
So wasn't from the video it said that it was like they started really believing it in like 1960?
So Alfred Wegener proposed this theory in the early 1900s, so like 1910 or something like that. But people didn't actually start to believe it until the 60s, which is like, I mean, my parents were born in the 60s. Right? Maybe your grandparents were born, I don't know. But really, like, this is very recent, okay? So his theory is that all of the continents used to be one big continent, and then that big continent broke up into smaller pieces. And that's why our map looks the way it does today. He called that continental drift. Okay, continental, it means the continents. Drift means to move, right? So his idea was that the continents all moved. Okay, so we are gonna watch a little video. I have 4 questions written down on this piece of paper. I printed them out because once I play the video, you won't be able to see them on the board. I don't necessarily want you to take notes written down on this, but I do want you to, as you're watching it, I want you to think about these 4 questions, because then we're gonna talk about it. So the first question is, what evidence did he use to propose this theory of continental drift? The second is, what did scientists think about that? What was missing from his theory? And then how did other scientists explain why the continents looked like they were puzzle pieces? They didn't believe in continental drift, they believed something else. Okay? So we're going to think about these as we're watching the video, and then we're going to talk about it. Nico. Okay, we'll talk about that in a little. Okay? Okay. All right.
He loved hot air balloons and even proposed to his girlfriend at home. Wegener was the kind of guy who couldn't sit still. That's partly why he gave up astronomy, the field he was trained in. One science was just not enough. To learn more about the Earth, he read any scientific paper he could get his hands on. Wegener was looking over an atlas when he noticed something curious.
Wegener later told this story himself. He said, I started looking at it, and it was really odd. He said, I'd always noticed that Africa and South America fit together. He said, but this map had information from deep down in the Atlantic Ocean. And what it showed is that that match between South America and Africa goes all the way along the continental shelf, all the way down to the foot of Africa. Now, if this is the case, he said, he thought immediately and pointed it out to his office mate, this isn't just an accident of sea level that these things look alike. These things look alike because they're connected in some way.
Almost for fun, Wegener developed an idea that continents were once connected and drifted apart over time.
Wegener's original idea about continental drift was a momentary intuition. For it to get to be science, you have to make the idea real.
In 2 years, he had found his evidence. A first clue was the Mesosaurus. Fossils of this prehistoric reptile had been found in both Brazil and South Africa. It was, Wegener said, too small to have swum 5,000 miles across the Atlantic. found a second clue in the Karoo Desert in South Africa. Here, massive glaciers had left giant scars and scrapes on the rocks. It didn't make sense. Glaciers in burning hot deserts? And what about the coal deposits found on the Arctic islands of Spitsbergen? Geologists knew that coal formed only in tropical forests. To other scientists, it was all a big mystery. To Wegener, these clues were the building blocks of a really radical theory. He proposed that all the continents were once joined in a giant supercontinent. He named it Pangaea. He published his theory of continental drift. This should have made him famous. Instead, he was bitterly criticized by leading geologists.
Many of them said disparagingly this was a theory of the Earth proposed by a weatherman, who moved continents around the way clouds move, but the Earth is this big solid thing. Continents don't just get up and skate around like pats of hot butter on a skillet.
Geologists had a completely different idea.
In the late 19th century, most geologists subscribed to a theory they called contraction theory. This was the idea that early in Earth history, the Earth was an incandescent globe of hot gases. Then, over geological time, as the Earth cooled, it continued to contract. And as it contracted, this crust collapsed. But the whole thing doesn't fall at once. Pieces of it fall first and then other pieces. And that's more or less how geologists imagine the Earth.
Wegener didn't buy this theory. He was sure he was on the right track and passionately defended continental drift. Although he educated himself well in geology, Wegener was still considered an outsider to the field. And there was one crucial weakness to his theory. How did the continents actually move? This he could not explain or prove.
Wegener didn't know what made the continents move, and frankly, I don't think he thought that was his problem. He thought that that was something that other people would have to work on.
Wegener would wait for the answer, but it would not come in his lifetime.
Alright. I'm gonna put the questions back on the board. You're gonna have 3 minutes to talk to your table group about these 4 questions, and then we're gonna go over them together. Be prepared to give me an answer. Okay? So you can either give your own answer or you can give an answer that somebody else at your table said. But I'm gonna call on people to give an answer. Okay? Alright, 3 minutes. Go.
That they fit together in like rocks and glaciers.
One thing that was alive and
that was a flaw, right? So a flaw or the part that was missing from his theory, right? So he didn't know how the continents moved, but he did know what.
He ate an apple and died.
So tell me, he knew that they.
What's the next question? How did other
They had
scientists
similar fossils. What else?
the gases?
In Africa, what?
what about
There were what? Fossils. Okay. Yeah. Yeah. Africa is hot. Alrighty, you've got 45 seconds to finish up your thoughts with your table.
Oh yeah. So this was what was
what was missing from the first theory, and one thing that was missing was he didn't know how to
Alrighty. Okay. Waterfall, waterfall. Okay. Let's see. Table 2. Tell me one piece of evidence that he used. Either Ricardo or Alexis. One piece of evidence that he used. Table 2.
On Africa there were fossils.
In Africa, there were fossils. Where else? In Africa and
Antarctica.
not Antarctica. Does someone want to help him out? Where were the fossils, Leo? South America. So Africa and South America had the same type of fossil, right? But they were separated by a huge ocean. Okay. Table 1. Tell me another piece of evidence. They fit together. That's right. So they fit like puzzle pieces, right? Table 7. Another piece of evidence. A piece of evidence for continental Earth. So we have fossils in 2 different continents.
They were like
Yeah.
coal deposits.
The coal. And where is coal usually formed? What do you say? Nicolo? In tropical rainforests. And where was it? Was it in a tropical rainforest? In Greenland. So it was in a place that is now cold, but we know that if there was coal, it needed to have been in a hot place at some point. Right? So the environment must have shifted. What was another piece of evidence that showed that the environment shifted? Table 3. Another evidence of environment change.
There were scratches in the
Scratches of what?
in the desert in Africa
Of what?
of glaciers when it's really hot. So glaciers.
Yeah. So another environmental difference, right? So there were some scratches of glaciers that are in a place that's really hot. So that means that continent used to be in a place where it was cold, and now it's in a place where it's hot. Okay? What did other scientists think? Table 5.
Other scientists thought that his theory was radical and not awesome.
Did they think it was correct?
No.
No. Most people at that time, actually pretty much everyone, thought that he was wrong, right? Why? What was missing from his theory? Table 4.
He didn't explain why they did what they were.
He didn't explain why they moved or how, right? He just said they moved. We had this giant continent, and then it broke, and it moved. And people were like, well, that doesn't make any sense. They're not like pieces of thing that can just move, right? And then table 6. How did other scientists explain why the continents seem to fit together? It starts with a C and ends with an action. Contraction. And what is that? Do you remember? Someone want to help out table 6? What is contraction?
It's where they thought like his
Earth started falling off little by little. That was their idea. Okay? So Alfred, what he saw was that he didn't buy into that, right? He said contraction doesn't really make sense. They fit like a puzzle piece. They have similar fossils. We can see that the environment doesn't make sense where they are right now. There must be something else. Elliot.
Wait, I have a question. The fossils that they found in South America and Africa, what where did like the fossil live? Like was there water anywhere? Or like a land?
There were actually, it wasn't just one fossil. It was a lot of different types of fossils. Some of them were plants, some of them were animals. I think the one that they mentioned in the video was like a lizard-like thing. But even if it was a water lizard, the ocean is way too far for it to be able to swim. Like it wasn't a swimmer.
Yeah, but how would it like be in the ocean if there was like continents? And if there wasn't any ocean between at all?
That's the point, right? That there wasn't an ocean there in between. And that's why he thought that the continents were once together.
But yeah, but then there wouldn't be ocean animals there because the ocean was constant.
Correct. So I think they were lizard-like things. I don't know the specifics about if they went in the water or not, but they were kind of lizard-like. Yeah, not ocean animals. Okay. All right. So what we're gonna do today? He has all of this type of information. This is actually some of the fossil information that Wagner found. Okay. I have a bunch of puzzle pieces here. What we're gonna do is I'm gonna pass out a piece of puzzle to everyone. In order to complete your puzzle, you need to find 4 other people, probably not people at your table. You're gonna find 4 people that have a puzzle piece that fits with yours. So a complete puzzle is 5 pieces. How many pieces is a complete puzzle? 5. What you're gonna do is you're gonna walk around and you're gonna try to find someone that has a puzzle piece that matches yours. Okay? Those 2 don't match. I'm just kidding. Well, if it fits like a puzzle, but their fossils don't fit, then that doesn't fit. Does that make sense?
Yeah.
Okay. It'll make more sense once you have it. So like you're trying to connect the 2 fossils, the fossil data together, like a puzzle. Okay? Make sense?
Yeah.
All right. I'm gonna pass these out. Once you get your puzzle piece, you can start walking around and finding your other puzzle piece friends. All right. Find a circle that matches inside. All right, puzzle pieces. Jansen, I'm gonna have to use them. All right, everyone walk around, push in your chairs, find your friends. So look at
Oh no, yours fits with Alex's. Who? Alex. This? Yes. With Alex.
I can't go to like that.
Remember, your groups have to be groups of 5. We need more people.
We don't have one yet. We already have one. We just need another one.
No, but it's the wrong sausage. So we need
Look
another
at
one.
missing. Which one are you missing?
North America.
No. Which one? So that South America used to fit with. You're in a group.
Alright, you have to follow us. Okay, I'll follow you.
Should I put my thing here? Right now.
We already had that one.
Oh my god! We have only a few minutes. Alrighty, waterfall. Alright, I need it quiet in 5. I need it quiet in 4, 3, 2, 1. Alright, you guys, I know this is exciting, but I need to listen. Listen. Alright. Go ahead and have a seat, please. Take your seat. Yeah, at your table. Leave your phones where they are. That's okay. Hold it. I know this was fun. We got to stand up, we got to talk, but now we have to listen. Okay. So if you're on the back side of the table, please go and take a look at the puzzle on table 3. If you're on the front side, come take a look at the puzzle at table 6. Those are the complete puzzles. So,
That looks good. This is very interesting. Yeah.
alright, once you've seen it, go ahead and take your seat. Go ahead and take your seat. Go ahead and take your seat. Alright. India used to look like it was by itself, like it was its own thing. And eventually India came crashing down with Asia and formed part of the new continent. We'll talk about why later. Okay, so what I want you to do, I'll come around and collect the puzzle pieces, but what I want you to do is, in your notebooks on that empty page, that Continental Drifts page, you are going to write a short summary of what we just learned. So 3 to 5 sentences, okay? It's not that long. I want you to tell me 3 things. 1, tell me what Wagner's theory was, right? Number 2, what evidence did he have? And number 3, what flaws did his theory have? There are some sentence starters down here if you would like to use them. You don't have to, but if you would like to use them, you can. You have about 7 minutes. All right, go. If anyone would like to do this together, you can meet me in the back table. Is that what you want to do? All right, we'll do it together. Everyone else,
This is Australia.
maybe 5 minutes.
Brother, just wait.
5 minutes. Make sure you're working. Access not granted.
No.
So Alfred Wegener proposed the theory of continental drift. That's what it's called, continental drift. It's up there on the board. Continental drift.
Which is the continents
How did the continents start?
like bunch of together.
Yeah, it started as one continent that broke up and moved. Okay? Yeah, I'll get some for you in a second. Okay? I'll get some for you in a second.
Yours? Oh, great. Okay.
You don't give us like wishes when they move somewhere?
I can see where you're going, but that doesn't give me enough information.
This one.
Which is
When the
they.
continents move.
What is they? Yeah, when the continents move somewhere else. Yeah. So don't just say they. I have no idea if you know what they is.
When the continents move, okay? M-O-V-E. Entonces, ¿qué es un
M-O-V-E.
Those are two pieces of evidence, right?
Cellular.
Coming. When you're done, please close your notebooks. You still have like 3 minutes left, so don't forget.
Evidence necessary to support reviews.
So what are some things that he saw?
Oh, like the
That-
puzzle pieces.
So they fit like a puzzle. What else? The fossils. Where did he find fossils?
On South America and Africa.
Yeah, so he found fossils in different continents. Right? The same fossils, different continents.
Oh,
Yeah, those are 2 pieces of evidence. Fossils in and done. And where else did he find fossils?
Africa.
there. No. Otra. This is space. M.
Okay. Is your notebook?
America.
is something that is a problem, right? So a flaw is a problem.
So like,
Yeah, so he couldn't explain how the continents.
nobody believes how you feel. He couldn't.
Well, that was the flaw. The flaw was that he didn't know how the continents. Did it Alrighty, we're gonna have to start packing up, so if you're not done, we'll continue this tomorrow. Class, please start packing up. Yeah, Valentine's tomorrow. Alright. Your notebooks in a stack, notebook, put them away. I'll take some. 10 billion.
Well, my work is like most important.